Hi everyone, we're going to start Module 14 today. We're still talking about proofs, but for Module 14 we're going to talk about triangles. We did line segment proofs, we did angle proofs, now we're going to focus on triangles. Now for today we're going to talk about just a couple theorems about like the specific angles in triangles. And to do that, let's start with a little bit of vocab. So first of all, an interior angle of a triangle is exactly what it sounds like. Interior means inside. So an interior angle is one of the three angles that are inside a triangle. Now exterior means outside, and an exterior angle is outside a triangle, but it's actually, you have to do a little extra work to create it. So an exterior angle is created by taking one of the three sides of the triangle, it actually doesn't matter which one, extending it, turning it into a line instead of a line segment so it keeps going, and then that creates an exterior angle outside of the triangle. So here's a picture of both. In this picture right here, we have the blue triangle, and I numbered the angles. I said angles 1, 2, and 3 are interior angles because they're inside the triangle. Easy. Now angle 4 is what we call an exterior angle, and you see I had to add to the picture. I had to take that pink line and draw it. I had to extend the bottom side of the triangle so it keeps going, and that creates what we call an exterior angle. Now I did it right there, but you can do it anywhere. Like I could have done this right here. I could have taken this side right here and extended it this way and called this angle 5. That's now an exterior angle too. So if you extend any one of the sides of a triangle, it creates an exterior angle. All right, so we have interior and exterior angles. Let's learn a couple theorems about those two things. We'll start with the triangle sum theorem. And it says the three interior angles of a triangle always add up to 180. That's a nice simple one, and it's a good thing for you to remember. So we're going to use that one. We'll use it in proofs as a reason, things like that. We'll use it actually several times this year. So make sure you remember that. That's a good one. And basically, if you go back to our picture that we just looked at, if you wanted to actually kind of create an equation for it, I said the three interior angles, that's 1, 2, and 3. Have to add up to 180. So measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180. Our second theorem is about exterior angles. Now this one, when you read it, might sound a little bit more confusing, but I'll show you on the picture. It's actually not that bad. It says the exterior angle theorem says an exterior angle is always equal to the sum of the two non-adjacent interior angles. Yeah, it sounds a little confusing, so let's look back at the picture. So an exterior angle, that would be number 4 here, equals the sum, means we're going to add, the two non-adjacent. Let's focus on that word. The word adjacent means connected to. So angle 3 and 4 are connected, they're adjacent. Non-adjacent means not connected. So angle 4 equals the sum of these two. If you add those two together, you'll get angle 4. Non-adjacent means not connected to. So not counting number 3, if you take the other two angles and add them up, you'll always get that exterior angle. So let's turn our two new theorems into an example. I'm going to use the same picture that we've been using with our interior angles of 1, 2, and 3, and then the exterior angles number 4 on the outside. And in my example, I'm going to say measure of angle 1 down here is 37 degrees, and measure of angle 2 up here is 28 degrees. And we're going to find both angle 3 and angle 4. Now, if I use each of the two theorems, I actually could find either one. So I could say, well, I know that 1, 2, and 3 have to add up to 180. I could find 3 that way. Or, and I think this one would be easier, I'll probably do this, angle 4 has to equal angle 1 and 2. So if I just add up the two angles that I see, it's going to give me angle 4. Let's do that. Let's say measure of angle 4, angle, equals measure of angle 1 plus measure of angle 2. That's the exterior angle theorem. That would be 37 degrees plus 28 degrees, 65 degrees. And that's the first part of our answer. We just figured out that angle 4 out here is 65 degrees. And a good thing to notice here, pictures are not always accurate. A book, it's called not drawn to scale. If you look at the picture, angle 4 is not 65 degrees. Angle 4 is like 130 degrees or something. It's like twice that amount. But that's okay, because angle 2 is not 28, angle 1 is not 37. We're just making up numbers and throwing them in there. So even if it doesn't quite fit the picture, that doesn't mean you did it wrong. That's called the picture is not drawn to scale. Okay, so now I want to find measure of angle 3. And the way I said I was going to do that first was I was going to do, okay, I'm going to say, well, I know the 3 of them all add up to 180. I can use that to find 3. Well, now that I found 4, I have an easier way. Angle 3 and angle 4 are a linear pair. They have to add up to 180. So in one step, now, I can find measure of angle 3 by just doing 180 degrees minus measure of angle 4, which is 65 degrees. And that would end up being 115. So we get 115 right here. And what you can do, in fact, this will just kind of verify the triangle sum theorem for us. Now that we have our answer, we can check to see if those 3 interior angles do add up to 180. So we can say, does 28 plus 37 plus 115 equal 180? And the answer is yes, it does. So we know we did our work right. But the answers to the question, angle 4 is 65 and angle 3 is 115. And one other thing is, I didn't do the proof with you today of any of these, but you can kind of see why these are true, why these two theorems both work. If these two add up to this one, these two have to add up to 180 because they're a linear pair. So these 3 also have to add up to 180. It's kind of like a transitive property. If 115 plus 65 equals 180, then 115 plus those other 2 angles has to also equal 180. So those 2 angles have to end up equaling 65. All right, let's do one last example. It's a solve for x question, or in this case, I guess solve for y. And remember, when you're doing a question like this, I told you earlier in the year for these geometry questions, there's 2 steps to this question. Step 1, you have to set the question up right. If you just look at it and go, I'm just going to say, 4y minus 4 equals 52 and solve for y. Or 3y, or just add them all up. Or if you're just doing things randomly, you're not going to get it right. You have to realize what theorem is being represented here and set up the equation right. Now the theorem that's being represented here is the exterior angle theorem. This is an exterior angle, so it equals this one plus this one, the 2 non-adjacent interior angles. So that's going to be my equation. The exterior angle, 52 degrees, equals, and then I'm going to add those up. I'm going to say 4y minus 4 plus 3y. And I took the parentheses off. It doesn't really matter if they're there or not. You can leave them if you want, but it doesn't matter. So that was step 1. I set the equation up right. I didn't just pick things and say, okay, let's make this equal that and solve for y. I really thought about it. I realized what theorem was being represented, and I set the question up right. Now, step 2 is to solve. So let's solve for y. I'm going to put that dotted line in here. I'm going to say I can do anything I want, as long as I do the same thing on both sides of that line. But before I do that, I have a common term. I have a 4y and a 3y on the same side of the equal sign. Let's add those together and get 7y. And then I'm going to leave that minus 4 that comes after it, and I'm going to leave the 52 over here. And then we'll solve for y. So I will add 4 to both sides. 52 plus 4 is 56 equals 7y. And then we divide both sides by 7. And y equals 8. 56 divided by 7 is 8. Okay. But that's not the answer to the question. That's the other thing I told you guys about these geometry questions. Don't just solve for y, put a box around it, and move on to the next question. You always go back and look for what you're being asked to find. In this question, I asked you to find the measure of angle W. Well, angle W is 4y minus 4. So what I want to do is I want to take that 8 and substitute. That will be my final answer. So angle W is 4 times 8 minus 4. 4 times 8 is 32. 32 minus 4 is 28. So final answer to the question is 28 degrees, not 8. Y does equal 8, and you needed to know that. But that's not what I asked you. I didn't say solve for y. I asked you to find that one specific angle. You had to solve for y and then use it to answer the question. So this one actually had 3 parts. I said every geometry question like this, every solve for x question has 2 parts. This one had 3. Part 1, know the theorem and set the equation up right. Part 2, solve the equation for y correctly. Part 3, answer the right question. We had to plug y back into the right expression to get the right answer.